instructions to the participants.
Okay. Okay, sir. Okay, sir. Very good morning to all the participants of ATAL FDP on Internet of Things. Welcome to the second day of our FDP. So I will be introducing you to our experts today. So our today's first session is conducted by Dr. C.S. Thakur. Dr. C.S. Thakur is Professor and Head of Computer Engineering Department of Government Engineering College, Rajkot. He has completed his graduation and masters from DDIT University with first class and has done PhD in computer science and engineering. He has almost 20 years of experience in academics at various institutes like DDIT Nadiad, Government Polytechnic Gandhinagar, LD Engineering College, Ahmedabad, and SS Engineering College, Bhavnagar. He is currently guiding.
Madam, just unmute yourself because there was some
Yes.
noise, so I have muted all. Okay.
Yes, sir. He is currently guiding 4 PhD scholars from Gujarat Technological University. He has published and presented more than 10 papers in national and international conferences and journals. He is currently the NBA coordinator of Government Engineering College, Rajkot. In addition to this, he has also achieved Best Paper Award twice in national conferences organized at Bardoli and Kadi. He has delivered various expert talks on topics like Internet of Things, machine learning, and cloud computing. He has been chairperson at International Conference on ICT for Intelligent Systems and ICT for Sustainable Development. In addition to this, he has also judged national conferences and poster competitions. He has customized a book on data and file structures by Pearson Education. He has also reviewed a book on fundamentals of information and communication technology for TMH publication. During this FTP, Sir has delivered one session on IoT architecture, and today he is going to deliver a session on IoT protocols. So this was the brief introduction about our expert for first session today. In addition to this, I would also like to give some instruction, very important instruction to some of the instructions to the participants. The first instruction is that e-certificate will be provided to the participants, those who have 80% of participation and are scoring 60% of marks in the quiz. So please make sure that your participation is 80% and you are attending all the quiz which are given during or after the sessions. Second most important instruction is please mute your microphone when the sessions are going on so that our expert can deliver their sessions to the best. During the question answer session, which will be organized after the completion of session, you can unmute your mic and you can ask the question. But after asking the question, please mute your mic immediately. Third instruction is that attendance record will be automatically fetched from the Microsoft team. So please make sure that you are attending the whole session fully. Thank you very much. I would like to invite Thakur sir to carry over the presentation.
Thank you, Vitlani sir, for giving me an opportunity to interact with these order stories for the second time on the Saturday. Thank you, Prapti, for your kind and generous. Prapti madam, my screen is visible.
Sir, there is some connectivity issue at your side, internet connectivity. Because of that, actually, we are also not getting your voice properly. Initially, when we started, it was perfect. Now screen is visible
at my end. Yes, screen
Okay.
is visible.
Screen is visible, but there is some jitter in my voice, or is
No,
it fine
now
now?
voice is also perfect. Now it is okay, right?
Okay, sir. Okay. Uh, uh, Please let me know because I have both the dongle ready. So I'll switch over the dongle if some kind of connectivity issue gets arise.
Sure, sir. We will give you immediately feedback, right? So please start.
Okay,
Now,
sir.
now everything is fine.
Fine. Thank you, sir. Thank you. Good morning, one and all. Participants of this ATAL FDP on Internet of Things. Today we will discuss uh, IoT protocol stack. Yesterday there were some threads on which we discussed IoT architecture. Today we will discuss protocol stack. Let me have the disclaimer kind of acknowledgement that the presentation acknowledges content which are images taken from Google. So the conventional or the default image URL is www.images.google.com, and these images are purely used for an academic understanding purpose. As I conventionally start my presentation with some of the finest quotes. So today the first quote is from Alvin Toffler. Toffler says the illiterate of the 21st century will not be those who cannot read and write, but those who cannot learn, unlearn and relearn. So this is the biggest challenge for 21st century learners, that we need to learn, unlearn and relearn. People who are computer engineering professionals or researchers, they quite agree with this, that computer branch is so rapidly changing. The change is the only constant, and it is very much prominent in the branch of ICT, that is information and communication technology. The second quote is very much relevant right now when we are taking online classes, we are having online FDPs, or our interactions with our relatives or our colleagues are using some kind of social media or online platforms. The second quote is very much relevant. Eric Coleman, he says, we don't have a choice on whether we do social media or not. The question is how well we do it. So and the third one is one of my favorites. Knowledge is having the right answer, but intelligence is asking the right question. So once we get knowledge empowered, we will definitely have right answers for so many technical, non-technical questions. But intelligence is something which will trigger us to ask the very right, very truthful questions, which will help us to dig more and more knowledge or to acquire more and more skill. So with these quotes, let us formally start our discussion. The flow of presentation for today's session is, first thing first, we will discuss Internet of Things ecosystem. I had some discussion in the last session. I will continue those threads and then we will start understanding major protocols. They are ZigBee, MQTT, SCOP, 6LoWPAN, LoRa. We'll try to have a brief about field bus, which is very much widely used in industry. To understand little bit about REST and Bluetooth. So these are the protocols we are going to cover. We'll try to understand, we'll try to acquire the basic understanding of the protocol. We will not go into the complete architectural description of the protocols, because keeping the time constraint in mind, I don't think it is that much feasible also, but we will try to see the major contribution of these protocols so far as IoT ecosystem is there. So first thing first, before proceeding towards understanding the IoT ecosystem, let us understand the hierarchy of IoT needs, that is Internet of Things need. So if you look at the pyramid has a bottom layer, which is nothing but the physical need. So what is the physical need of IoT and the security need? These are for existence purpose. So if I talk about physical need, it is about power, connectivity, climate and value. All those devices which are part of IoT ecosystem, they have their own value addition towards the ultimate goal. The ultimate goal might be for monitoring purpose. The ultimate goal might be for control purpose. The ultimate goal might be to update the environment or to save the climate. So that actually covers the physical need of the devices. Power and connectivity for self-existence. Battery backup devices are there. Power is one major area. So any person who is part of the embedded system design, or any person who works with IoT application or system development, they have to definitely consider these two major existence or existential aspects: power and connectivity. Then comes security needs. You know that security is a major threat and it's a challenge also. But please note that IoT security is a very big career opportunity also. So there are encrypting part, encoding part, and authentication and authorization part, which is very much there in the security need for self. Then comes self-expression. So when we discuss this IoT hierarchy, self-expression is very much, because the device is lying somewhere, maybe in a farm, maybe having an RFID tag, maybe it is part of the supply chain, maybe it is part of some consumer goods manufacturing company. The devices or the sensors or actuators there, they might be part of some kind of office environment or corporate culture. But how do they express, how they get noticed, how they get collaborated with other devices or with servers and other kind of gateway kind of stuff? So that actually fulfills the connectivity needs. So if I want to fill the vacuum for connectivity needs, I have to, as a developer or as a programmer or as an embedded system designer, I have to focus on three major aspects: interface, communication, and networking. How can I make that device very much part of my networking setup? How that device communicates with the coexisting devices in the eastbound interface, and how the very same device gets communicate with northbound interface, or maybe to the cloud or to the phone. And how can I build an intelligent interface? But if interface is having all the features of like microservices, it would be a very lightweight device, and this lightweight device gets connected to interface very easily. Now when I say lightweight, lightweight means the code footprint is very small. Even when it is communicating, the code footprint should be very small, and that's why MQTT or COAP, this, when we will discuss these protocols, you will feel that their code footprint is small, and because of that, they are actually satisfying the connectivity needs of the IoT requirement. Then comes the data need, because ultimately by all these devices, what do we generate? We generate data, and in modern context, it is said that data is the new oil. Any company which has tremendous data, which has smart algorithms to handle the data, and which has either the cloud or the residential processing power to crunch this data, that company can be the next billionaire company. So data is very important, and Internet of Things actually generate a lot of data, and this lot of data actually comes in three major formats. Either they come through transactions, or they become part of log, because if I'm measuring temperature, if we continue yesterday's example, if there are 50 sensors, if there are 50 IoT devices in a hall measuring 5 different parameters, and if they are measuring every 5 seconds, you can imagine the log part. Likewise, diagnostic purpose, medical and other kind of applications are there, where diagnostic is something which is very tricky. It is very crucial also, and it is majorly real time. So data needs, so connectivity need and data need, these are two needs which will definitely help us for self-expression. So IoT hierarchy peculiarly says that connectivity needs and data needs, they are actually very much part of our IoT setup. Then comes self-actualization. Now this is the top of the pyramid. So if I take the bottom-up approach, I'll definitely try to create node setup, and then I'll go for connectivity, security part, then I'll go for data crunching part. But ultimately, to make my applications run very smoothly, to make my application give me business intelligent decisions, I need self-actualization. What is that? That includes predictive behavior. That includes logic, learn, and analytic part. Analytic is something which is very tricky because I have big data, but if I do not have platforms like Hadoop or some kind of fork computing, I cannot have the analytics. So with this hierarchy of IoT thing, I think we can understand what we mean by protocol stack. What protocol is how we are going to govern. Protocol is how we are going to operate. What are the nomenclature for any device to get operated or for any program to behave in some particular, the rules, the regulations which we specify is called protocol. And what do we mean by protocol stack? Protocol stack is nothing but we are formulating these rules in a very well-defined, well-drafted manner, and we see that the devices and the standards and the development programs or microservices actually work accordingly. So that's called protocol. So now we come to IoT ecosystem. Before we go to IoT ecosystem, let us try to understand the four major component of this slide. One is devices, second is gateway, then comes IoT platform, and then those applications which serves the purpose like analytics and diagnostic and control and maintenance part. So if we look at the devices in an internet era, the devices are in terms of thousands or lakhs, that is tens of thousands. But when we talk about IoT, devices can be 5, it can be 50, it can be 500, it can be 50,000, it can be 2. In a large company setup. So devices are obviously going to be there. But here we are not going to discuss devices which are full devices in terms of computing power, memory, and all this. Some of the or majority of the devices are going to be constrained devices. Now this term we have discussed in the same understanding. Constrained devices means limited processing power. That is number one. Unreliable networking because of mobility, because of wireless connectivity, unreliable networking. And number 3, low power, because majority of the devices sometimes run on batteries. So constrained devices, and the network is also called constrained network. Now what do I mean by constrained network? Constrained network is a network which has got this kind of limitations and which is made up of largely these constrained devices. Now once we understand devices in the ecosystem, let us go to the gateway. So when we try to understand gateway, actually edge or the bottom of the pyramid has devices and the top of the pyramid has cloud. So cloud has servers and edge has devices. So edge forms the bottom part of the pyramid or the bottom part of the architectural setup, and cloud forms the top part of the architectural setup or the pyramid. Now at edge, if we look at very carefully, devices are not gateways. Devices, what are they? Devices talk to other devices northbound and southbound. That is the coexistential setup of the devices, where multiple sensors or multiple actuators or sensors and actuator combinations talk to each other. That is called north. So gateways talk to the cloud. If I want, because devices ke upar gateway. So gateway is one hierarchy up to the devices. Gateway talks to the cloud northbound. But when gateway wants to talk to devices or when gateway wants to interact with devices, it has to talk to southbound. And particular scenario gives us two kinds of communication. One, device to device communication and device to cloud communication. Now our protocol should cater to this need regarding device to device and device to cloud communication. But before we formally understand this, we need to understand gateway. What is a gateway? It is a pipeline. Now why do we need this pipeline? We need this pipeline go to that slide, which can make us understand why do we need pipeline. So this slide has three internetworking parts. Number one is Internet of People, that is internet-enabled personal electronics like phones, tablets, and computers are there. And through consumer applications, they are connected to Internet of Things. Now, devices with IP addresses. So they are, I should say, big things, or they are little bit big devices. Now, when I say big devices, it does not reflect the size. It actually reflects that they do not have power problem and they do not have bandwidth issue. And if required, they have the computational capability also. So we call them Internet of Things with IP addresses. And these devices can have open source hardware. It can have a proprietary software or an open source software. So they are well equipped. Now the third and the largest bubble shown in the slide is other ID and sensor systems. That is Internet of Things without IP address. Yesterday also we had a discussion. Now these devices have RFID, active RFID tags, some kind of sensors and other stuff is part of this. These devices are called non-IP things and they need to get connected to the internet. They are not directly connected to the internet. They are Zigbee empowered. They have Wi-Fi and Wi-Pro and Bluetooth connectivity setup embedded with them, but they are not directly connected to internet. And these devices are called non-IP things. And these non-IP things, when I want to get connected to internet, I need gateway. So gateway is, in a layman's term, it is a pipeline. It is a pipeline where non-IP devices and IP enabled or IP devices or resources get. Now this working is through gateway. So gateway architecture is there. Now what is a gateway architecture? You can have IoT servers, like full-fledged servers, portals, big data, cloud servers, and then you can have gateway. Now this gateway is taking care of the configuration management, some kind of dynamic data model, and managing some kind of complex circuitry. Now this complex circuitry actually forms, so gateway is a pipeline, and through this pipeline it is connected to IoT platform. So once we understand this ecosystem, once the ecosystem is clear in our mind, we can concentrate on this slide. This slide actually talks about the web stack and the IoT stack, and there are various layers. If we look at this Ethernet, ISDN and wireless LAN, that is IEEE 802.11 standards, Wi-Fi, IPv4, IPv6 at the internet layer, and then TCP, UDP, HTTP, DHCP as the application layer, they are there. And they support HTML or XML or JSON. So extensible markup language or JSON or HTML is part of it. And the top of it is nothing but web applications. So it's a web stack. Now when we formally understand these web stack, and we are very much aware with IPv4 or TCP, UDP or wireless LAN or Wi-Fi Ethernet part. So we are well familiar with this web stack. Now we focus on the left side of this pyramid, the protocol stack, IoT stack. Now this stack actually talks about IEEE 802.15.4, that's Zigbee. So Zigbee is formulated on this IEEE standards 802.15.4, and we are going to discuss Zigbee as one of the first protocols as part of our this session. Then comes 6LoW WPAN. Then comes COAP and MQTT. So this all is part of our discussion. So this slide is actually briefing you about what we are going to discuss and why we are going to discuss, because you can very easily compare our web stack with our IoT stack. It's almost been 10 to 12 minutes. So let me confirm one more time, maybe sir or madam, am I audible? Hello.
Yes, sir, you are audible.
Yes.
Yes. And the presentation is quite visible, and is it going smoothly?
Yes, yes, sir.
Okay, thank you, sir. Thank you. So this is the complete protocol landscape. You can see the connectivity part where there is Modibus, wireless, RJ45 connectivity devices, and then you can have link protocol layer where we have Bluetooth, we have Zigbee, we have 802.15.4, Ethernet. They all coexist. As I told you, it's an evolutionary technology. It is not revolutionary technology. So GSM and RFID is there, Ethernet is there, and it coexists with our Zigbee and other standards. Then comes 6LoWPAN. After 6LoWPAN, we have COAP, MQTT. So this is what we are going to discuss. You can very easily see the protocol landscape is has its own size and depth, and we cannot discuss the complete landscape in one session or multiple sessions, but we'll try to cover maximum so far as protocol, transport and session layers are concerned in this landscape. So this is all about the layers on one side and the protocols which are working on those layers on the other side. At transport layer, you can see 6LoWPAN. Network layer, you can see LoRa. LoRa is also part of our discussion. We'll have discussion on Bluetooth. So once my brief introduction gets over, let us start with our first protocol. And I'll take this protocol and I'll try to give you very basic understanding and working of every protocol which is part of our discussion. So Zigbee is a wireless technology standards, and it is a standard base. It enables low cost, low power wireless machine to machine and Internet of Things network. So M2M connections and IoT was part of our discussion yesterday also in architecture part. So low cost, low power wireless. Zigbee is for low data rate, low power applications, and it's an open standard. Now, when we compare this Zigbee with Wi-Fi networks to connect endpoints in high-speed network, Wi-Fi network has this high-speed network as part of its consortium. Zigbee supports much lower data rates, and it uses mesh networking protocol to avoid hub devices, and it creates a self-healing architecture. Now, this self-healing architecture is very much required for our IoT setup. So that way, when it is low power, when it is low data rate, and when it is creating self-healing architecture, I think Zigbee is a very prominent player in our IoT protocol stack. So Zigbee is targeted at the battery powered devices in wireless control and monitoring applications. Now, wireless control and monitoring application is perfect test bed for IoT setup. Zigbee delivers low latency communication, and it is typically integrated with radios and with microcontrollers. So getting integrated with radios on one side and with microcontrollers on the other side, Zigbee is the perfect launch vehicle for our IoT setup. Now, in which band it operates? Zigbee generally operates in ISM band, that is industry, scientific and medical radio band. It's a license-free band world over. The world organizations have consented that this ISM band, that is 2.4 GHz band, is going to be license-free. So product developers can create protocols and standards and products in this, and they do not have to bother about taking the licenses or federal government licenses when they launch these products in various countries. So that is the biggest advantage of creating any protocol or any standard in this 2.4 GHz band. Apart from this 2.4 GHz, in China, it is also functional in 784 MHz, 868 MHz in Europe, and 915 MHz in US. Now, when the 868 MHz, that is China, the data rate is supposedly 20 kbps, and when it is operating in 2.4 GHz, the data rate it supports is 250 kbps. So from 20 kbps to to 250, but still it's a low data rate system. ZigBee is built on physical layer and media access control. So IEEE standard 802.15.4 is a very well-known standard. And on these standards, there are two major layers, physical and media. So ZigBee is built on these two layers. And that's why it is said that ZigBee is a standard base, open standard base. That is 802.15.4. And it is for low rate wireless personal area network. So wireless personal area network standard is called IEEE standard 802.15.4, and ZigBee is developed for that. The another prominent feature why ZigBee is very much in market for IoT setup and IoT kind of environment, implementation environment, is it facilitates for carrying out secure communication. So it is basically built on basic security framework, which is defined in this IEEE standard. So it is built on this basic security framework, and it is built on the physical layer and the media access control layer of this IEEE standard 802.15.4. ZigBee style self-organizing ad hoc, that is, it was launched in 1990s, and then the ZigBee specification was ratified in December 14, 2004, and then another version, if I'm not wrong, actually came in 2008 or 2014 also. ZigBee protocols are intended for embedded applications and low power consumption and low data rate. So any embedded application which has low power consumption and low data rate requirement, ZigBee is a very suitable candidate for that. So there are many typical application areas for ZigBee. One of the conventional area for ZigBee is home automation. Controlling various devices from various intelligent interfaces like microwave, oven, or the water, or the temperature sensor, or the air conditioning part. Home automation is one major application area for ZigBee. Wireless sensor network and industrial control systems. ZigBee is a major player. Embedded sensing, medical data collection. Medical data collection requires multiple ports are there, and it requires very small but very critical real-time data rate communication between the devices which are connected to a patient, and ZigBee is very much operational there. Smoke warning and intruder warning. This is modern day requirement. Building automation. If I want to build any automation system, ZigBee is one major player. Remote wireless microphone configuration. So when we look at the figure given in this slide, you can very easily see that there are two major layers, applications and application profiles at the top, and there is a MAC and physical layer operating at either ISM band or the conventional 868 or 915 megahertz. And between that, there is an application framework and security layers of the ZigBee protocol. So ZigBee protocol this is how the protocol layer can be defined in ZigBee. Now, once we understand ZigBee, the next major discussion part is MQTT, and we are going to discuss MQTT in a very detailed way. Let me share some very basic understanding of MQTT. MQTT stands for Message Queuing Telemetry Transport. It is based on publish or pub subscribe based lightweight messaging protocol. So number one, it's lightweight. Number two, it's messaging protocol. Number three, it has a very small code footprint. Now this is very much required in an IoT setup. Very small code footprint is a catch. Another one is it is used on top of the TCP/IP protocol. It has got a limited network bandwidth for constrained environment. We already discussed what do we mean by constrained devices, what do we mean by constrained network. So limited network bandwidth for constrained environment is very much part of message queuing telemetry transport, that is MQTT. It is data agnostic, data neutral. So MQTT transport messages between devices. The protocol usually runs over TCP/IP. That doesn't mean it is only bound to TCP/IP. Any network protocol that provides ordered, lossless, bidirectional connection can support MQTT. So any network protocol that provides ordered bidirectional connection, and if it is lossless, it can support MQTT. It is specifically designed for connections with remote locations where a small code footprint is required. Because network bandwidth is very limited, network power, these constraints are very much prominent in IoT setup, and that is why it is specifically designed for connections where remote locations have a very stringent requirement of small code footprint, and there MQTT is a perfect fit. So MQTT protocol is defined over two types of network. There are two major types of network entities. Number one, MQTT broker. Number two, MQTT client. So what is a MQTT broker? Let us understand. It's a server and it receives all messages from the clients and then route these messages to the appropriate destination clients. So it receives the messages and then it routes messages to the clients also. So MQTT broker is bit heavy. It requires some computational power. So MQTT broker is bit heavy and some computational memory requirement is there. Broker is the single point of failure, and we'll see that in a figure also. And information is organized in a hierarchy of topic. Now, what do we mean by topic? Suppose I'm interested in knowing the temperature. So that temperature becomes topic for me. So basically, there is a set of clients which subscribe to various topics, and there is a set of publishers. We are publishing these topics, the value for these topics. If there is a client number one who is interested in temperature, there is a client number two who has subscribed to pressure, and there is a subscriber which is periodically measuring temperature, then this subscriber is giving this data to broker, and broker is publishing this data to the client which has subscribed to temperature. So in a sensor environment, wireless sensor network or an IoT setup where I'm interested in knowing certain parameters, certain features, I can as a client subscribe to this data, and the subscriber can pass on this data through this broker architecture to me. So the second entity is MQTT client. Now what is a client? Client is any device. It can be a microcontroller or it can be a full-fledged server also. And it runs on MQTT library. So the only requirement is it should run on this MQTT library and it should be connected to MQTT's broker over a network. So there is a broker, there is a client, and there is a library. So once this broker part and the client part is understood, you can see here there is a temperature sensor and it publishes the temperature data. In this case, the example is 28 degrees Celsius. And what is the name of the topic? Topic means the parameter or the entity in which I am interested. Who am I? I am a client. So if I'm a client and if I have subscribed to knowing the temperature as a client, I can be a device, because in IoT we talk about machine to machine communication. So as a machine, if I have subscribed to temperature topic, I have subscribed to a temperature topic as a PC or a laptop. Likewise, I am another client, client number 2. I can be a mobile device. I have subscribed to temperature topic again. So this subscription is registered with this and MQTT broker takes care of giving me the data. What is the name of the topic? Temperature. And for this topic, the message given by this temperature sensor is 28 degrees Celsius. That is the current temperature it has sensed. Now this temperature is given to MQTT broker. Now broker, as soon as it gets the temperature, it publishes the data on temperature topic. So one more time I go to my conventional setup. What was my conventional setup? I was talking about big hall industrial setup where there were 50 IoT devices, sensors and actuators and all this. And these 50 devices were actually measuring 5 different parameters. So these 5 different parameters can be considered as a topic. And these devices and whoever is interested in getting the values, they can be outside the hall, but there can be hundreds or thousands of systems or devices or nodes or laptops or mobiles which are interested in knowing the value. And they subscribe to these 5 different parameters. And there are 50 devices, and through MQTT broker, hello, through MQTT broker, all these external devices which are connected to this IoT setup will get the parameters. In this case, in this slide, the topic or the parameter which is being sensed, which is being published, is temperature. And the value right now which is being published is 28 degrees Celsius. So that is the published data, 28 degrees Celsius, to both the clients which are subscribed to topic name temperature. So this, once we understand this, we'll try to still elaborate on the publisher part. So when a publisher has a new item of data, like if the temperature has risen from 28 degrees Celsius to 30 degrees Celsius. So when the publisher has a new item of data to distribute, it sends the control message with the data to the connected broker. So it will formulate a very small, tiny control message, and we'll also see the size of this control message. It will send this control message like 30 degrees Celsius to connected broker. Now what will the broker do? The broker will distribute the information to any client which has subscribed to that topic. Any client, any device which has subscribed to this topic called temperature will get an update. What is the update? Earlier it was 28 degrees Celsius, now it is 30 degrees Celsius. Now the publisher does not need to have any data on the number or location of the subscriber. Publisher do not have to bother for this. And subscriber in turn do not have to be configured with any data about the publisher. So you can see this broker, this is a very perfect, because interdependency is not there. Publisher does not bother for subscribers or the location of the subscribers. Subscribers in turn do not have to configure for any data about the publisher and the forms and formats. The only thing is it has to, as a subscriber, I have to, as a device, I have to register for the topic. And in this case, the topic is temperature. And the value newly fetched is 30 degrees Celsius. Now let us come to the middle, that is the broker. Now, if a broker receives a message on a topic, let us say temperature update. Now the temperature update is 30 degrees. For which there are no current subscribers. If the subscribers are not there, then the broker will discard the message. But broker has to retain the message if the publisher of the message has designated the message as a retained message. If it is a completely real time, then I will not, as a publisher, I will not put the tag. उसपे ऊपर मैं tag नहीं लगाऊंगा कि ये retain करना है ये message को. Otherwise, I'll put that message that it's a retained message. And a retained message will not be discarded by broker. A retained message is a normal MQTT message with the retained flag set to true. So there is a flag, and the retained flag is true. And once it is true, the broker stores the last retained message and the corresponding QoS for the selected topic. And we'll discuss, there is a separate slide for QoS, what do we mean QoS. So this broker will store the last retained message. Now, if you get another message like 29 degrees Celsius, and if this 29 degrees Celsius is again having the retained flag true, then the broker will keep that 29 degrees Celsius retained message. So once the broker part is clear, each client that subscribes to a topic pattern that matches the topic of the retained message, it will receive the retained message. In this case, that is now 29 degrees immediately after they subscribe. Now, if I'm a new subscriber, and if I just I have subscribed for the topic called temperature, I'll get the latest retained message. In this case, it is 29 degrees Celsius. Now the broker stores only one retained message per topic. For every topic, the broker stores one retained message. That is the latest one. It allows new subscribers to a topic to receive the most current value rather than waiting for the next update from a publisher. So what is the advantage of this retained message? As a subscriber or as a subscriber, you don't have to wait for the temperature to get updated by the publisher. Whatever was the last value, I'll get that. Now, when a publishing client first connect to the broker, it can set up a default message, and broker detects that the publishing client is unexpectedly disconnected from the broker. Now, what will happen? Client will only get interact with the broker, but a system may contain several brokers. So now we talk about the system. Now the system can have several broker servers that exchange data based on current subscriber topics. So there are many subscribers topic. So minimal MQTT control message can be as little as 2 bytes of data. Now you can imagine that's why MQTT is very much prominent in the conventional IoT implementation and setup. The minimal MQTT control message is 2 bytes of data. But this control message can carry, because client jo hai, it can be a server also, full-fledged server also. So a control message can carry nearly 256 megabytes of data also if needed. So look at the range, 2 bytes to 256 megabytes of data that control message can carry. That's the maximum it supports. Now let us come to MQTT. It relies on the TCP protocol for data transmission. It integrates with that. There is a variant MQTT SN. It is used over other transport like UDP and Bluetooth also. MQTT simply with TCP protocol, but MQTT SN, it can bind with UDP or Bluetooth also. MQTT sends connection credentials in plain text format, and it does not include any measures for security authentication. You can have TLS for encryption and protection purposes, for interception or modification or forgery kind of stuff. The default unencrypted MQTT port is 1883 and the encrypted port is 8883. Now we'll focus on MQTT broker. Some important information and some repetition. A software running on a computer, running on premises or in the cloud, could be self-built. So what is a broker? It's a software which is running on a computer. It can be a local server or it can be a cloud server. It could be self-built or hosted by a third party. It can be available as an open source or a proprietary. So any kind of possibility exists with MQTT broker. Now the broker acts like a post office. It doesn't use the address of the intended recipient for the particular topic. Anyone who wants a copy of that message will subscribe to that topic. Each client can both procure and receive data by both publishing and subscribing. So client can have both a publisher and a subscriber, but basically MQTT is a pub subscribe protocol and it's a messaging protocol. Earlier, if you recall, we used to have this push-pull architecture. So you can imagine this. With MQTT broker architecture, the devices and application becomes decoupled and more secure. That is the advantage. Because of this broker architecture, the publisher is a separate entity, operationally independent. The client and its subscription is a separate operational entity, and that is why the devices and applications become decoupled. And they are more secure. So this is again there is an on-premise for an on-premise analytic purpose or for a cloud analytic purpose. I have subscribed to a topic called humidity, and there's a humidity sensor, and there's a publisher, and this publisher actually gives the humidity value, that is 32%. And then MQTT broker actually publishes this 32-degree humidity value to this cloud server or the local server for an analytic purpose also. Now, what are the main advantages of MQTT broker? Number one, It can easily scale from a single device to thousands. This is a perfect fit for IoT setup. Scalability. Number two, it eliminates and insecure client connections. Number three, it manages and tracks all client connection states along with security credentials and certificates. Very tiny certificates are formed and they are checked and they are validated before giving the value. If they are like stock market values, so certificates need to be validated that whether the request is coming from a very authenticated stockbroker or not. Reduce network strain without compromising the security, because you have seen that almost 2 bytes or 4 bytes of control messages. So network strain is reduced. So it is a good, it provides a good operational environment either for a cellular or a satellite network. Now, quality of service is very peculiar. It's very tricky to understand. What is the quality of service? Each connection to the broker can specify a quality of service. Now, there are three major types of quality of service. It can be either 0, it can be 1, or it can be 2. If it is 0, the broker or client will deliver the message once with no confirmation. That is at most 1. The message is sent only once and there is no additional steps to acknowledge delivery. It's like fire and forget. Fire and forget. Then it is quality of service 1. That is at least 1. What is at least 1? The broker or the client will deliver the message at least once with confirmation required. So the message is retried by the sender multiple times until acknowledgement is received. So it's called acknowledged delivery. So this is quality of service level 1, 0, 1. And then 2. The sender and receiver engage in a 2-level handshake to ensure only one copy of the message is received. It's called assured delivery. So MQTT quality of service has 3 major parameters: fire and forget. It operates on 3 major types: fire and forget, number 1. Number 2, acknowledged delivery, that is at least once. And number 3, exactly once. What is exactly 1? One more time. The broker or the client will deliver the message exactly once by using a 4-step handshake. So 4-step handshake can be used in this 2-number quality of service. So 0, 1 and 2. So this is the figure to understand this quality of service, where temperature sensor is there, motion sensor and moisture sensor. And for any of this topic, so once this MQTT is understood, we can switch to another protocol. It's called COAP, Constrained Application Protocol. Now, what is the core objective? You can see that the figure has internet and it has got the server, and HTTP is working very well. And there is a proxy, and to this proxy, there are many devices which are connected to this proxy using COAP. So what is the role of COAP? Let us understand first. Core objective is to bring running success of HTTP in the world of IoT. Through COAP, the great success of HTTP, because we know web, www and its proliferation, and the success story of HTTP and the combinations of HTTP with TCP IP, we are well familiar with it. If I want to bring the same success story in the world of IoT, I need COAP. So it is lightweight and it is called fast HTTP. It uses the same principle of that of HTTP. Same principle. It is based on the same principles of HTTP. COAP is a transfer protocol for use with constrained nodes and constrained networks. Now we have already discussed what are constrained nodes, and we have already understood what do we mean by constrained networks. So constrained node and constrained IoT, constrained networking and IoT, COAP is a transfer protocol. It is designed for manipulation of simple resources on constrained nodes and networks. I can manipulate these resources using this. COAP is designed to be extensible like HTTP. The way HTTP is extensible, COAP is also extensible. So this is very brief about Constrained Application Protocol, COAP. Let us try to digest the very basic information. It's a specialized internet application protocol for constrained devices, and it is specified in this RFC 7252. It enables constrained devices to hold nodes to connect with the internet using SIM. That means COAP is designed for use between devices on the same constraint, low power, lossy network. How does it take place? This communication, this transformation, this transfer will take between devices and general nodes on the internet. So if I have devices which has COAP support and I have general nodes which are connected on internet, yes, the communication can take place. And between devices on different constraint network, both joined by an internet. It is also possible with, suppose there are 3 constraint network. Let us call them constraint network 1, 2, and 3. With this 3 constraint network, between 2 constraint network, there are many devices and they are COAP enabled. So communication can take place between among these devices also. COAP is also used with other mechanisms also, like SMS on mobile communication network. So that makes it more extensible and more widespread use. People who understand service-oriented architecture can very easily get understood. COAP is a service layer protocol. And as we know, it is made for resource constrained internet services like wireless sensor network. It is designed to translate to HTTP for simplified integration with the web, while also meeting specialized requirement like multitask support. Now we need to understand what is multitask support. HTTP is synchronous messaging. COAP is also synchronous messaging. Suppose one room, let us understand multitask support. What do we mean by multitask support? Suppose, let us take one case scenario. There is a room which has multiple lights. Now, if MQTT does not support multitask, so if I want to switch off these multiple lights simultaneously, MQTT cannot help. But COAP is required to make them off, because multiple lights can be made off simultaneously using COAP, which is not feasible with MQTT. So this is a very simple scenario to understand this term called multitask support. So COAP is designed for constrained environment. Number 1. It meets very specialized requirements like multitask support. It has very low overhead and simplicity. So multitask, low overhead and simplicity are extremely important for Internet of Things. And that's why I told you that COAP is very suitable for constrained networks, constrained devices, Internet of Things or machine-to-machine devices kind of setup. Efficiency is very important. COAP can run on most devices that support UDP or a UDP analog. It can run on those devices also. Now, if I compare COAP with HTTP, if I take a web object and this web object is HTTP based, then it requires, to formulate it, it requires hundreds of bytes. But this web object is connected to IoT backhaul, then IoT backhaul does not require hundreds of bytes. It only requires 100,000. Instead of thousands of bytes, IoT backhaul requires only hundreds of bytes. And it is connected to IoT backhaul. This web object is connected to IoT backhaul using proxy. And this IoT backhaul is connected to IoT node network. IoT node network only requires tens of bytes. So web object, hundreds of bytes get connected or get integrated or get collaborated with IoT backhaul setup, hundreds of byte requirement, it decreases. And then IoT node network, tens of bytes. So that is the simplicity part. And it has a very low overhead. So low overhead, multitask and simplicity. That is very important for IoT and machine-to-machine devices. Internet Engineering Task Force constrained RESTful environments. And there is a working group called CORE, Constrained RESTful environments. It is called CORE. And it has done major standardization for this protocol, COAP. Now, to make this protocol suitable for IoT and M2M, various new functions have been added. And this is called RFC 7252. So they have revised COAP, this group CORE, Constrained RESTful Environment Working Group. And this working group has made or added new functions, and it is specified in RFC 7252. All the participants who just want to dig more into the functional aspects of COAP can refer this RFC 7252. So there are many important extensions attached in this RFC for various stages of the standardization process. Now we'll discuss COAP message formats. The smallest COAP message is 4 bytes in length. If we omit token, options and payload, if we take them token, options and payload, obviously the size will increase. But if we omit them, the smallest message would be 4 bytes. It uses two message types, request and responses, with a very simple binary header format. The base header may be followed in options like type, length, value format. So it basically follows this type, length and value format. COAP is by default bound to UDP and optionally to DTLS. So by default it is bound to UDP. It provides a very high level of communication security. Any bytes after the header in the packet are considered the message body. The length of the message body is implied by the datagram length because it is bound to UDP. So datagram length actually limits the message body part. When it is bound to UDP, the entire message must fit within a single datagram, obviously. But when we use them with 6LoWPAN, then it should fit into a single ZigBee frame. IEEE 802.15.4. I should not use IEEE 802.15.4 as interchangeably as ZigBee because ZigBee is actually built on this IEEE standard 802.15.4, specifically the physical and the MAC part. But if I want this COAP message to be fit into 6LoWPAN, then it should be like 802.15.4 frame to minimize the fragmentation, because if the size increases, then if it does not fit in one frame, then I have to create another frame. That's called fragmentation. So to minimize fragmentation, it should fit into single frame if I'm using it with 6LoWPAN. But if I'm using it with UDP, then it should fit into single datagram. If the UDP datagram is 1500 bytes, the message body and the message header part should not exceed more than 1500 bytes. That's called datagram part. And it can also get connected with 6LoWPAN provided single IEEE 802.15.4 frame. So we already discussed, we have already coined the word 6LoWPAN. So let us take this. 6LoWPAN is an acronym for IPv6 over low power wireless personal area network. So you can see IPv6/6, low power, LO, and wireless personal area network. Personal area network, we are quite familiar with. So WPAN. 6LoWPAN is the name of a concluded working group in the internet area of the IETF, Internet Engineering Task Force. IETF is responsible for such kind of standardization. They form certain groups also, which we call core groups, is one example. So Internet Engineering Task Force is an apex body which takes care of this standardization part. The 6LoWPAN concepts originated from the idea, दो idea में से एक, the internet protocol could and should be applied even to the smallest devices. Why 6LoWPAN got made, originated? Number one, IP should be applied to smallest devices. And number two, low power devices with limited processing capabilities should be able to participate in Internet of Things. Any device which has low power, which has limited processing capability, matlab constrained device, any constrained device should be able to participate in the Internet of Things. So there are two major driving force for 6LoWPAN to come into existence. Number one, IP should be applied to the smallest devices. Number two, any constrained device, that is low power or limited processing capability wala device, should be able to participate in IoT. 6LoWPAN group has defined encapsulation and header compression mechanisms to realize these two dreams. It allows IPv6 packets to be sent and received over IEEE 802.15.4 base networks. So any network which is IEEE 802.15.4 can encompass IPv6 packet to be sent. So IPv6 packets I can send over this 15.4 base network. And how do I send it? For that, I have to encapsulate it and I have to do the header compression mechanism. Because IPv6, you know, it is 128 and it has got its own size, and the packet has its own structure and all this. And 15.4 is wireless, this standard. And if I want to fit it into it, I need to do encapsulation and I need to do header compression. Well understood. IPv6 and IPv4 are the workforce for data delivery for LAN, MAN and WAN for an internet. We know the significance of IPv4 and IPv6 so far as the working success of LAN, MAN and WAN is concerned. Likewise, IEEE 802.15.4 devices provide sensing communication ability in the wireless domain. If I want to bring the same kind of, because LAN, MAN and WAN majorly are initially when they were formulated and majorly they are wired networks. Definitely infrastructure, it has got Wi-Fi embedded with it, but majorly the success was because of the wired part. If I want to bring the same kind of stuff in the sensing capability or sensing communication capability in wireless domain, I need to develop a new standard. And that new base specification standard was developed by 6LoWPAN IETF group, that is called RFC 4944. But it is not limited to that. It is not limited to 802.15.4. IPv6 over Bluetooth low energy, that is BLE, is defined in RFC 7668 also. Now, what are the application areas? Because 6LoWPAN, we understood objective, we understood how it got fitted, we understood who actually formulated it, standardized it, where it is applicable. Yes, we understood it. Now, we have to focus on application areas. So the target for IP networking for low power radio communication is the main application area. That means wireless internet connectivity.
Excuse me, sir. Thakur sir.
Ji, sir.
Now, just now, actually, voice breaking has started. Just now. Previously, it was perfect. Just within few seconds only. Right?
Okay, sir. Okay.
Okay.
Okay, sir.
Maybe drink a glass of water and then.
Yes, sir. Yes, sir.
Yeah. Okay.
I'll also change the perhaps I have to reconnect. Sir, is my screen visible?
Yes, your screen is visible and now audio is perfect.
Okay, sir. I have switched to the second dongle, so I
All
hope
right.
that.
All right, all right.
Thank
Now
you.
it is
Thank you,
fine.
sir.
Everything is fine.
Yes, thank you, sir. So now we'll focus on the application areas. Now there are two catchwords. One is wireless internet connectivity and at lower data rates. For what? For devices with limited form factor. Devices which has limited form factor, I need to get them connected to internet. Now why we need to connect them to internet? Because in IoT discussion earlier, I discussed that through gateway, we always try to connect devices which are non-IP based devices to IP based network, that is internet, to servers, to proxy servers, to cloud servers for analytics purpose, for application development. So that's why this target is set up. So application area is not just for the sake of creating these applications. It's a need, and the need is focusing on two major parts. One, wireless internet connectivity, and wireless internet connectivity at lower data rates. Now, what is the example? Example is automation and entertainment applications in home, office, and factory environments. Because I need to get connected. I have a very limited capability devices, and on this limited capability devices, whether they are in home or office, I need to get connected to internet. Maybe I want to download something. I want to watch a video. All these kinds of requirement. And for that, header compression mechanisms are standardized. Now we are standardizing these compression mechanisms. Why? So that we can have this 6LoWPAN successful in IEEE 802.15.4 setup also. That is why. So IPv6 also is used in the smart grid, smart meters. So smart meters are there. People come to your households. They come with a device, and this device is connected to a smart grid, and they have these meters in their hand, and they actually, so when they sense the meter reading, they actually build a micro mesh network before the sending data back to the billing system. Because why this electricity meter reader come to your campus? Just to get the meter reading. Now when he comes for the meter reading, he is actually having a very small device, and this small device is very much part of a micro mesh network. Because if I talk about torrent company or any other electricity provider company, there are many people, there are 100 people simultaneously visiting various societies physically with these meters, and then they actually sense the meter reading. Now when they are part of a micro mesh network, and this micro mesh network sends this data back to the billing system using IPv6 backbone. So the billing server is internet connected. It's a heavy duty server, and it has got a IPv6 backbone. But these smart meters or the meter readers do not have devices which have computational power or enough memory kind of stuff. They are very tiny devices, and through these tiny devices, every day they visit 100 households, and with 100 households, with 100 ID numbers, they actually do this. They perform this meter reading. But when they perform this meter reading in a real-time scenario, in a real-time momentous moments, this meter reading data is fed back in a micro mesh network, and this micro mesh network actually combines this data, and then it sends this data back to the billing system. So now the attendees of this FDP can understand that what the 6LoWPAN actually provides us. So some of these networks may run over IEEE 802.15.4 also radios, and there are other constraints also. But still, what we try to do is we just try to realize the dream. What was the dream? It was IP could and should be applied even to the smallest devices. That's why 6LoWPAN was conceptualized. That's why it was formatted and formulated. And there are devices now. So low power devices, and what was the second dream? Low power devices with limited processing capability should also participate in the Internet of Things. So if we understand these two major driving lines, we can see that a smart grid meter reader can take this, and there are 100 people and there are 100 such households. So every day the person visits 10,000 or perhaps more than 10,000, but this data is given to the billing system or the billing server, which is IPv backbone. And here you can see that there are 6LoWPAN wireless module. These are cloud servers. Now let us assume that your billing server is there in the cloud for torrent, and it is internet connected. And there are cloud and wireless modules connected directly via IPv6. So you can see the 6LoWPAN setup, and through this 6LoWPAN setup, these meter readers are there, and these meter readers are actually fetching the reading data. That is the previous and new one. Now come to the second, another protocol that is called long range. It's a low power wide area network. Now comes wide area. We made it with UDP, then IP, now wide area. So we are trying to cover majority of the protocols in every segment of the conventional internet to the Internet of Things. So this lecture should be seen that it's a holy matrimony between the conventional internet setup and the Internet of Things, and how Internet of Things protocol actually helps us realize the conventional internet connectivity and data transfer dream possible using these protocols like LoWPAN or LoRa or ZigBee. And I think that's the main objective for this also. It's a low power wide area network protocol, and this was developed by Cicelo of Grenoble, France, and it was acquired by Semtech company. It's a founding member of LoRa Alliance. So this LoRa is basically based on spread spectrum modulation techniques. We are quite aware with spread spectrum. Direct sequence spread spectrum is a major topic when we discuss mobile computing and wireless communication. So people who are familiar with wireless communication, they understand what is frequency hopping or what is a spread spectrum. So LoRa is based on spread spectrum, where we use chipping sequence. In this case, it's called chip spread spectrum. In conventional spread spectrum, we use chipping sequence. So one bit is formulated using this available bandwidth, using like multiple XORing operation, like original bit XORing operation, and then chipping sequence gives us a larger bandwidth chips. So it is based on several spread spectrum modulation, and this modulation employs chirp spread spectrum, that is CSS technology. And it was developed by, as I said, a person from France, and this company was then acquired by Semtech. Now LoRa uses license-free sub-gigahertz radio frequency band. Now three major points. It uses license-free bands. Second, it uses sub-gigahertz band. That is 433 megahertz. In Europe, it is 868 megahertz. In Australia, 915 megahertz. Australia and North America same. And 865 megahertz to 867 megahertz in India. So LoRa in India is based on 865 to 867 megahertz. And in Asia, it is 923 megahertz. So it's sub-gigahertz band. That is important because it is for wireless area network. Wide area network, sorry, not wireless, wide area network. LoRa enables long range transmissions like more than 10 kilometers in rural areas with low power consumption. Now the technology covers the physical layer, like other technology protocols cover the upper layer. So LoRa is based on the physical layer. The other technologies are network and session service layer and all this. It can achieve data rate like 27 kbps to 0.3 kbps depending upon the spreading factor. 2018 January, the new LoRa chipset were announced. And what was the striking features of these new LoRa chipsets? Number one, reduced power consumption. Number two, increased transmission power and reduced size. Now LoRa devices have geolocation capabilities and trilateral positions, like from 3 points I can locate any object on the earth, trilateral positions. LoRa and LoRaWAN permit long range connectivity for Internet of Things devices in different kinds of industries. Like if I talk about very large setup industries in a very large area, so LoRa and LoRaWAN actually supports long range connectivity, and the range extends to LoRaX also. Now I finished these protocols. I was bit fast, but it is almost 8 to 9 minutes remaining. So let us discuss field bus. So what is a field bus? It's little bit misfit for this this title, protocol stack, but I thought let us discuss field bus. So field bus is industrial digital bus for real-time distributed control. And when it is where it is mainly used, it is mainly used in manufacturing, like assembly lines, process control industries. It connects instruments in the shop floor. So using field bus, I can connect instruments in the shop floor. And it supports different topologies, daisy chain, trees topology, it's been supported. It is cost effective. Now when I say cost effective in Internet of Things domain, what do I mean by cost effective? Less cable and maintenance, because we are talking about digital bus, so less cable and less maintenance is called cost effective for field bus. Then comes REST. REST stands for representational state transfer. It is basically an architectural style and it is used to define APIs. Now REST is basically a PhD thesis written by some foreigner. I forgot his name, but it basically, so any service which suppose REST API or which suppose this API is called RESTful. So REST API or an API that is RESTful, it's not a protocol. It is neither a language nor an established standard. It is basically an architectural style, and it's an architectural style used to define APIs. Now, why am I discussing this? Because API has still its major role in creating the IoT setup. So there are many APIs which are RESTful and they are part of the industrial or the development environment. There are 6 major constraints that API has to follow. Any API, क्योंकि वो architectural style है. So any API that follows these 6 constraints is called RESTful. Now the objective of this 6 constraint is to maximize the scalability and interoperability of software interactions. Now that is why I have kept this in the presentation. Why? Because if I need to develop applications for analytics, for control, for maintenance in IoT environment, I need to take APIs into consideration. And if my APIs are RESTful in nature, what it will give me? It will give me scalability. Now scalability is a very integral part of IoT setup. I cannot think about an IoT setup or an IoT workforce without scalability. And the second one is interoperability, because we know that inherently IoT is going to be an heterogeneous environment. And when it is an heterogeneous environment, I need to have something which has interoperability as a prominent software interaction feature. So that's why REST is being covered. There are REST constraints that now what does this constraint says? It says REST does not define on specifics of an API, but it imposes certain constraints on the nature of interaction between applications and service. How this application and service is going to interact. So the constraint is basically focused onto it. REST emphasizes on a uniform interface between components, and it enables controller services to evolve independently and provides ability for SDN, that is software defined network, to use software components from various vendors. Now, this is also one of the IoT requirements. It has been very successfully implemented in the conventional internet domain or internet enabled web domain. Internet enabled web domain APIs, RESTful APIs, they are very successfully implementing. We have already discussed many protocols, COAP, MQTT, we discussed field bus, all this. If you want to repeat the same success story, LoRa we have discussed, what we need is, we need the services to evolve independently, and it should have the ability to use software components from various vendors. And by doing this, let us build a very robust controller environment for monitoring and control purpose. For that, identification of resources, because if I bring this analogy, the RESTful API analogy to IoT, number one is identification of resources. You can have multiple diverse heterogeneous resources and they are identified using an URI. Then can I manipulate these resources using representations? So JSON, XML, HTML, they are represented in these formats. Can we have the subsequent formats in our IoT setup? And if they are there, how am I going to use them? And then self-descriptive messages. The messages which are self-sufficient, the message which says what is to be done. The very last portion actually talks about Bluetooth. We are quite aware with Bluetooth. It's a universal radio interface for an ad hoc wireless connectivity. We know what is a piconet. Bluetooth devices, 8 devices forms piconet, 1 master, 7 slave. Why only 8? Because the addressing bit is 3 bits. So 2 raised to 3 is equal to 8. So we can only have 3 active devices. We can have, it is one of the standard. It is short range, like 10 meter. Now it has gone beyond 10 meters. It operates on 2.4 gigahertz in ISM band. It is for voice and data transmission. We are quite aware with Bluetooth. Harald Blackburn, and he was a son of Grom, and he unified this Denmark, these Scandinavian countries in the 10th century. Based on his name, this Bluetooth Foundation was formed in 1998. The first standard actually came in 1991. But that is not the point of discussion. The point of discussion is in 2005, every week 5 million Bluetooth chips were sold. Scalability part. Please focus on this. These are the characteristics of Bluetooth. It operates on 2.4 gigahertz ISM band. There are 79 RF channels. It is for both voice link as well as data link. If it is a voice one, it is SCO, that is synchronous connection oriented. If it is data link, it is ACL, asynchronous connection less. And this is the piconet setup. What is a piconet? It's collection of devices which are connected in an ad hoc fashion. One unit is a master, others are slaves, and all communications actually happens through master. There are part devices that can be standby devices. Part devices can be more than 200 because the addressing scheme for part devices are 8-bit. So 2 raised to 8 is 256. So there can be more than 200 devices. But why only 7 slave devices? Because one is master and the addressing scheme for this active devices are 3 bit. So 2 raised to 3 is 8. So I cannot number more than 8 devices. So that's why every Piconet has a unique hopping pattern that we all know. And with this, I conclude my session. I could cover few protocols and their very basic understanding and why they are needed, what were the objective to formulate them, and let us end this with few quotes. Focus on the destination, not the difficulties. That is quote number 1. And the second one is work hard in silence. Let success make the noise. So the final quote is one of my favorite: embrace technology, but do not become it. So with this, I conclude my session. Thank you very much. And I welcome questions.
Thank you very much, Dr. Chirag Thakur, sir. You have given, in-depth idea of IoT protocols. Because just after this at 11:30, we will start some experiments on MQTT protocols. So yes, this session will be very much useful to the participants to understand the programming of how to upload the sensor data on cloud, and what is that API key and what is token and everything, because all that background they have now. So it will be very much useful to them during the hands-on the sessions, right? Thank you very much, sir. Meanwhile, and I also salute your time management, perfect, exact. So I request participants, if you have any doubt, any query, you can unmute your mic and ask, or otherwise you can also write in a chat box. In both way, you can ask the questions. Sheikh Sakil.
Hello. Hello. Hello, sir.
Yes, please speak up.
Hello, sir.
Please ask.
Hello, sir. So my question is that, suppose there are some IoT platform providers. So at which stage?
Sir, please unmute yourself. I think someone has muted you.
So my question is, am I audible, sir?
Hi, yes, you are audible.
So my question is, suppose Idea customer is there, suppose Geo customer is there. So at which place it will get, at which stage of the IoT structure it will get differentiated, that which from which provider it is coming. Suppose mobile message or anything.
Okay. Digital check, analog check? Digital. Okay. I will also try. Thakur sir, I think you are muted. We could not listen you. So please unmute yourself.
Okay. Yes, sir. Your question is pertains to the application part of the IoT platform. You just want to know. You just want to know. And I just want to determine which network provider am I accessing right now. Am I right?
Yes, sir.
Yes. So for that, sir, you can build application. So I give you one example. Suppose I have 5 devices being connected, and these devices are operational on different internet service providers. Now to sends them the existence of the devices and the various service providers, what I need to do is I can build a small Python code and I can run into an Android. So I can create an Android app, or I can run this microservice level Python code through which I can find out that what kind of internet service provider right now I'm accessing. Or you can also dig into the parameter part, that right now these two providers, what kind of services or data speed they are offering me simultaneously, based on which I can switch over from one internet service provider to another internet service provider. Is it fine, sir?
Yes, sir. Yes, sir.
Okay.
So thank you, sir. Thank you very much, sir, for providing.
Thank you, sir. Ji, sir.
One participant, Then Mozi, I think she is from Sairam, Chennai. I got one WhatsApp message that you cannot upload that pre-test, but I think your response is already recorded. Can you tell me something? What is exactly a problem? Please unmute your mic and tell me. Then Mozi from Chennai, Sairam, Chennai. I got WhatsApp from you, but then when I checked, your response is already there. It is recorded. Many of you are facing the issue, so that's why I launched the test link again. It was open up to 9:30 a.m. today, and many of you have already submitted it. So, and regarding learning resources, all the learning resources are uploaded in a Microsoft Team under the file section, as well as few of you are finding difficulty in accessing that material. So we have created Google Classroom. So you can also join the Google Classroom, and from the Google Classroom also you will get the material. If you have any doubt regarding how to get the material and all that, you can ask. And if you have any doubt related to IoT architecture also, you can ask, because Chirag sir is also with us.
Yes, yes.
So my question is that.
Yes, sir.
So, not question, my suggestion is that before starting the next session, if we will get the material before that PPT, so that we can see and we'll learn
I
better
think
than
Mr. Sheikh already, this session number.
I already downloaded.
Yes. Okay.
But
it's already there.
Yeah.
Chirag sir has also, uploaded it just before that.
Yes,
sessions are also uploaded. Only pending is session 6. We are waiting from expert. Whenever expert will submit, immediately we will upload it, right?
Okay, sir. Okay. Thank you very much. Thank you.
Welcome, sir.
So I think we will end this session here, because we have to meet again at 11:30. So let us take a break. But now it's my, request to all the participants that you left this meeting. You leave this meeting and join another meeting, because what happens yesterday, there were 2 meetings were in parallel. So you should leave this meeting. This meeting is already over. Then you can leave this meeting, and then after you join another session. So some separate link is given for session 5.